Okay, so a mid-segment of a triangle is clearly a segment that joins the midpoint of each side. So it's a segment that joins the midpoint or midpoints of the sides. Now let me ask you a quick question. If I were to draw you a random triangle, it could be a right triangle, it could be obtuse, it could be scalene, whatever. How many mid-segments could I draw? So let's say I calculate the midpoint. And let's say I pick this side. That's a mid-segment, correct? What if I pick the midpoint over here? Then couldn't I draw it this way? Couldn't I draw it this way? How many mid-segments could I make? So 3? What if I do in here? 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 Yeah. So this is called Stravinsky's triangle. I think I've told you guys before about Fibonacci. I know we used to do it in algebra class. So Fibonacci is a sequence. See if you can catch my pattern. Yes, I'm adding the 2 in front, right? So 3 plus 5, 5 plus 8, and I could keep going, right? This is called Fibonacci sequence, and Fibonacci was a guy, Italian, who tried to blend math with nature. So he studied things in nature like seashells and different things, and he found that they followed this pattern. Stravinsky was a guy who tried to blend math kind of with art. And so what he did was he took different types of triangles. It doesn't have to be isosceles or equilateral. He took lots of different types of triangles, and he basically created the mid-segments. And, I mean, I guess as big of a triangle as you want to start with, I mean, you could just keep going and going and going. Then he even got so crazy as he wanted to create a formula to predict how many triangles there would be. Now, this right here, you got to be careful. When you look at this picture obviously is one triangle. When you look at this one, it depends on what you count as triangles. So if you count 1, 2, 3, you got 3. But some people count 1, 2, 3, 4, and then the whole one's 5. So depending on how you count it, though, he created this formula. So what you can do is you can like predict the number of triangles and how big the triangles will be with how long the sides are and all kinds of stuff. And I mean, kind of to me you might think, okay, this guy needs a life, like he's, got a lot of time on his hands. But this was in 1915 he did this. Like, I mean, I hate to even say, but just maybe calculating midpoints and all that kind of stuff when was the ruler invented? Like, when did they have accurate devices for some of this stuff? So it's kind of, I don't want to say interesting, but back to our question here is that you can have infinite number of mid-segments. Now, our class is not going to do that, but if you do look on the back page here, we do have a few mid-segments in this diagram. So they're just going to take it and go smaller and smaller and smaller to see if you understand the concept. So, here, in this box, the relationship that you need, if I go back to this other drawing, not only do you need to know that it connected the midpoints of the sides, but you need to understand how these two pieces work with each other. So would everybody agree that they're parallel? So if I grab this and I move it, do you see how it stays parallel to the bottom? Or if I go like this, it stays parallel. Now I can't change the mid-segment, like in this program. I can't move this to here. But if I could, it would stay with they call it the third side, okay? The other thing that they want you to notice, which is very difficult to see from this drawing, is the relationship with how long it is. So I'll just tell you. So we go here. So we know it's parallel. And then the relationship is that the mid-segment is always half as long. And I'm going to say as the third side. These two pieces of information is pretty much what your homework is about. Half as long, I would probably say, is about 90% of all the homework questions. So if you understand this concept, it goes very fast. The parallel piece, they do ask a few questions, but not that many, okay? So let's go through these as, I don't want to say as quick as we can, but stay with me and we'll get through this, we'll get done with this very fast. Number 1, how about Elena? What's this mid-segment X? DE. How long is it? Correct. It's half of 28. Now reverse it. They give you the mid-segment. So how about Taylor Wilson? 30. You just double 15. Now notice number 3, they don't, here's my mid-segment and then here's my third side, but they're not asking me about that. Look over here and the X is on the side. Now they're really asking you about the definition. The definition tells you this is a midpoint. So how about Sydney? What's the answer for 3 then? 9. Done. Do you see how fast these are? Just like yesterday's homework. Now you know they're going to give you some little algebra expressions, so take a look at number 4. The mid-segment is half as long, correct? So how do I figure this out? Because I can't just take like half of this piece. What do I do? Ben?
You do 3n plus 12 equals 2n plus 14.
Okay, so you're doubling the n plus 14.
Yeah.
Okay, so you're doubling this piece. Now, I totally agree this will work. Did anybody view it slightly different? Taylor? So you went like this, and then you set it equal to n plus 14. Will it make one bit of difference? No. It won't matter one bit. I may not do this just because I don't really like to do 3 divided by 2. Not that I can't do 1.5n plus 6. I just don't necessarily love decimals. What if I wanted to avoid the decimal here? Do you know how to avoid it? What if I don't want to do this? Because what if this was I don't know, like a harder number? How could I avoid this decimal? Do you remember? Yeah, I could have just multiplied each side by 2. That would cancel this out, and notice it would leave me in the exact same scenario. It does not matter which way you do this, so I'll just quick write this one down. I would move the 2n over if it was me, because I like my variables positive. I would subtract the 12. Now, do I have to plug it back in? No, it asks me for n, so I'm done. How do you guys feel with mid segments? You like them? Okay. Again, I don't feel like chapter 6 is really that difficult, but what I do, in my personal opinion, is each lesson in chapter 6 is very independent from the other lessons. And sometimes I think it can be confusing if you just try to open up the book and like read the book to try to figure out the concept. So if you're here, again, we can get through these pretty fast. So that's why I said if there's anything you want to retake or make up, if you came in Monday morning, we could go over an old test. You could even like start it after the lesson on Monday because I don't think these are going to take that long. Okay? All right, take a look at 5. Seems like it's awfully bright up there or something.
Yeah, it's not. Is
No.
it still the lights?
I don't know. I don't know why. It's not really any different. Maybe because my computer is right there. I don't know. That's not really. Is it because it's brighter outside today?
Well, no. Is it like the light on the projector?
I don't have one of the little switches for lights. Like some of them have a little switch right here that it projects a light down. Mine doesn't have that.
Might just be like the position of
I don't know.
the camera.
It's what?
I said it might just be like the position of the camera.
Yeah. Well, let me know if you can't see something or you're confused, but it does seem like it has a weird glare to it today. Okay. HJ. This is what they want us to find. Let's just make sure we label the 2 pieces that they give us just so we don't get confused here. All right, I quick labeled the 2 pieces. Do I take half of one of them? Do I do half like we did before? Or double one? Can I double this one? I'm stuck. What do I do? Ella, what do I do? Do I do half? Do I double? I double the short one? Okay, but remember, this mid-segment is half as long as the whole thing. This piece is only right here.
Oh, I thought you.
This is a mid-segment right here. Okay, how about Emma? Why'd you set them equal? Yeah. Okay, hold on. Shh. So we should just set them equal. I guess what I wanted to show you, right, Anna? What I wanted to show you was the fact that you don't always just double one. So don't just assume, because the problem before you, that you doubled it, okay? So I'm setting them equal. I'm going to go ahead and solve this. And then, Emma, you can tell me what to do next. I'm going to move the 5 over. So that'd be what, 23? Oh, half of 23. Not really loving the decimal, but I guess I can do it. So you doubled this, but the side isn't m. The side is 3m plus 18. Okay, so let's plug it in. So if I plug it in, I get 52 and a half.
And then you would multiply that by 2.
Yeah, because 52 and a half is only this piece. So then I just have to double 52 and a half. So I get 105. That seems like an awfully large number for a side, but we don't know the units in this particular case. I mean, if it was millimeters, that wouldn't be very much, but if it was like, feet or something, inches, then it'd be a lot. So don't look at the numbers thinking, oh, that seems too big or whatever. All right, how about 6? Good old perimeter. Haven't seen that word in a while. Nice thing is you don't have to do the perimeter formula. A bunch of my algebra kids on system of equations did not do well with that part. It said something like the perimeter was this, and then it was like the length is 6 more than the width or whatever. Seems like they all forgot the 2L and the 2W. They all tried to do L plus W, and then got the wrong answer. Okay, what do I do here, Ben?
You divide each by 2.
Okay, so you want me to go through and divide each number by 2. Now, at first I was a little confused. Does this number, like the 45, is that the whole length of the side or is it just one part? So I did have to look in the the teacher's book for it, and it's the whole side. That one, if you got stuck on, you could definitely ask. Okay, Ben, I divided them all by 2, but what does this do, or what am I supposed to do with these numbers?
You add them up
Why do I add them all together?
because those are the perimeters of the mid segment.
Okay, so all of these numbers, like half of 45 is 22 and a half. So Ben basically took half of these numbers to give you your triangle. Now, this works perfectly fine. Ben's answer is correct. But does anybody think of it a different way? Do you have a question?
Yeah, so are all the triangle on the inside, those are all mid-segment?
Yes. Now, if you weren't in this chapter, like let's say you're like on the SAT or something like that, what I have typically seen on the SAT is they will tell you in the directions how somehow that it's a mid-segment.
Okay.
In this chapter, they're assuming that you just know that they're all mid-segments.
Could you just add
Listen,
could you just add the numbers all together and just divide by 2?
that's what I did.
Okay.
So what I did was I found the perimeter of the large triangle, the whole big triangle, and then I knew that the inner triangle was basically half as big, so then I just divided by 2. Notice you get the exact same answer, so it doesn't really matter which way you do it, okay? I just wanted to show you that there was an alternate way. All right, we only got one question to go. You need to make sure you're paying attention to this because, again, these are very similar on the homework. Then I'm done, so we'll be done very quickly here, okay? 7, bunch of mid-segments. We're finding FJ. That teeny tiny little one right there. What do? Start me off. How about Aubrey?
Would you use the 33?
Mm-hmm. What would I do with the 33?
Would you have to divide it more than just by 2 because it's...
I would start it first by dividing by 2.
Okay.
That's going to give me GC. GC is 16 and a half then. What do I do now?
And then would you divide it by 2 again?
What's that going to give me?
Would that one be okay?
No. If you divide this by 2, that would give you this. But dividing it by 2, if H is a midpoint, doesn't that tell me that this is 8 1/4? Now, isn't FJ a mid-segment of this one? So now I got to divide it by 2 again. And now I have my answer. It's sort of like a mid-segment of a mid-segment of a mid-segment. You got to like keep going lower and lower and lower. All right, how about the next one? EH. How do I get EH? How about Lauren? How do I do EH? Do I use the 33? No, it's not really part of that triangle.
You divide you add 22 to get the total at the bottom.
So this is 22, this is 22, so you're telling me that this is 44?
Yeah, and then G across would be the mid-segment.
Yes, but I don't really want that. I'm not disagreeing that that's not the mid-segment.
Then you divide that by 2 to get the smaller one.
Okay, it will give you the same number, but think about this triangle right here. If this is 22, couldn't I just take half of 22 to get this part? Okay, so just kind of try to watch what mid-segment it is. I told you, almost 90% of the homework is the sides. You remember the other part of the definition? It's almost like they forgot this part, and then all of a sudden they're like, ooh, let me throw a question at you regarding the parallel piece. So you are not going to see hardly any questions that deal with parallel, but there are a few. So let's take a look at the angle questions. DCG is right here. Angles and sides. Don't mix up the numbers. So if this is an angle, take your eyes towards the only angle that they give you. Now ask yourself, what relationship do those two angles like have? Like, are they vertical? No. Are they a linear pair? What are they? Angles cannot be parallel. Only lines can be parallel. Ben? They're corresponding. And if this is a mid-segment, that means these lines are parallel. Corresponding angles are congruent. Corresponding and alternates are equal. Same side are what? Same side are what? Supplements. Okay? So let's do this last one. FJH. Man, I can hardly like put a little mark right there. FJH. Right? Where my pen is, right there. Kind of bluish. Avery, what do I do?
I said that it was 123.
Why?
It would be like a linear pair of 57.
Not a linear pair.
Not that one, but like a different one.
Okay, so here's the bottom. There's the original 57. Here's the 57 you just found, correct? Here is H. I'm kind of drawing this to exaggerate. Here is EH. Here is the J1 that they want you to find, correct? These are corresponding. Aren't these two corresponding? So this is 57. Now I'm not sure, you said linear pair. Did you take this one and go over here then?
Yeah.
So then this is corresponding? And then she did linear pair? Now I didn't do this one, Avery, not that it makes one bit of difference. I did same side interior. So then I took 180 minus the 57 and got the same number. Only I used same side and Avery used linear. Okay?